we will see today a short introduction course. Today is our first lecture, so it will be a short one. Mode of learning. This is about programming. So programming the microcontroller. So I will teach all the theories and concepts which is behind this microcontroller and programming. But of course, you have to spend more time to practice yourself and learn by yourself how to do the programming and do several practice projects or some sample projects. I have uploaded some sample codes that you can also practice. Here, the beauty of this course is you do not need to write the C programming from scratch. So the IDE, the tool will generate the C code based on your configuration. And then you just have to insert some lines, some codings here and there, and then you will achieve the function, whatever you want. So I will explain those things later. Those are technical details, but just you should know this course, especially this programming oriented courses. This is more about self-learning. So you have to give more importance to this part. So the course objectives and contents. So the objective of the complete course is, especially for the microcontroller part, to give the basic knowledge of STM32 microcontroller. So this is the STM32 is one of the several other microcontrollers. There are some other families also, but nowadays STM32 is dominating the entire market. I will tell you the market share in a while, but STM32 microcontroller, if you study about this, of course, you can apply the same principle in other microcontrollers as well. So the course contents or the curriculum is like this. First, I will give the introduction to microcontroller. And of course, you better use the hardware abstraction layer, or simply we can call this as a HAL, H-A-L, HAL library. So we will use the HAL library or hardware abstraction layer programming in this microcontroller. And you will learn about reset and clock control system, clock control and system clocks configurations, that is RTC, real-time clock. And also we will see about GPIO, that is the general purpose input output configuration. What it means? It means, every microcontroller or microprocessor has pins, input output pins. So we are giving input to the pin and we are also getting output from the microprocessor. So we can configure these pins in different modes. So we will see about this GPIO configuration. And then we can also see about interrupts, different types of interrupts. Interrupt means like you can pause the process, or you can stop the process temporarily in the microcontroller. And whatever the request is coming as an interrupt, the microprocessor will process those interrupts. After it complete the processing of those interrupts, then the microcontroller will move back to the main program. Anyway, we will see those details. Just interrupt means this is the meaning. And direct memory access, we will see. So I will tell you why this is called direct memory access. The last semester, if you took the course communication networks, you might have some idea about the memory, how it works. So here, this is called a direct memory access. So it means microcontroller, it has the onboard memory. And sometimes we also get the data from external memories. So without using CPU resource, how can we transfer the data from memory to the processor to handle the data? So that is what direct memory access. We will see the detail later in the upcoming lectures. We will also see the universal asynchronous receiver transmitter mode. So this is simply, it's called Uart. So because in each microcontroller, we have the receiver pin and transmitter pin. So how we are going to configure those pins and use those pins, those details will be discussed under this topic. And later we will see the timer and ADC. This is really a very practical function of microcontroller. we can set up the timers, and how can we use the ADC. ADC means analog to digital converter or digital conversion, we can say. And also we will see the SPI, simply we can call as a SPI, serial peripheral interface, and also inter-integrated circuit, I2C or I2C, we can say simply like that. So we will also see the detail of these things. And finally, we will see the power control, PWR. This is the course contents. So in all the microcontrollers, these are the basic concepts we are going to use. So that is what we are going to cover in this course. Okay, textbooks. So here some textbooks are suggested, but really learning from the textbook about microcontrollers is really something funny. It's not very practical. So you can read textbook somehow, but you have to learn this from online sources and some learning materials which are shared in Canvas, because mostly you can learn everything about the microcontroller from its reference manual and the data sheet. So remember, reference manual and data sheet. So each microcontroller has its own data sheet that you have to see. So all the details are given there. So how can you configure the pins? How can you use the DMA timer and so on? So those details are very important. Textbook means this is really just focusing on one very narrow topic. So that will not cover different microcontrollers. So for example, in our course, maybe we will use STM32F103 microcontroller during the lecture, and the sample codes also you will see that. But in the project, maybe you will be using another microcontroller, STM32L476. So F103 and L476. So for example, these two microcontrollers maybe you will be using. So the textbook, yes, it's good to read, but I personally suggest you do not limit yourself within textbook. And also refer the materials which is shared in Canvas, especially nuclear board with 50 sample projects. I have shared one PDF, so you can go through that, and also the reference manual and other relevant materials, whatever you prefer to read or watch, that is okay. So that is why I mentioned refer online materials and forums, etc. So this is the basic for any programming. So you should do that if you want to be a master of programming.